Today I'll talk about the problem contact. So this problem is a bit tricky. You cannot just store the strings and compare which one has the greater occurrence. You have to convert, since these are only 0 and 1s, you can convert these subsections into decimals, from binary into decimals, and then you will be able to store them in a array, so you can keep track of each of the frequencies. So here's my code. It actually isn't that complicated. I would say most of the stuff here are actually just to make this is just to make the output correct, because it has a really specific format for the output. So here's my code. I have to read this through several lines. Each line only contains 80 characters or less. And the reason I added an extra 0 to the end of the string is for later uses, so we don't exceed the limit. So here we'll have a loop. The I indicates our starting index, and we will, as I said, we'll convert them into decimals, from binary into decimal. So here is the bitwise operator. This means left shift, and what left shift does is that, for example, if you have a few numbers, left shift just adds another 0 at the end of it. This is the same thing as multiplying by 2, but I want to specify that here we're dealing with binary numbers, so I'll kept this left shift, and then we'll set this. So now after we shift, we'll have an extra empty 0, and we'll set that to whatever is in the index of the string. So this is I plus j. We will get the index, because at least we know that this string should at least have a length of a. So this is what this does. Starting from any index I, we will have to loop from 0 to a first, so we can get at least an m with length a, and then we will check all the other numbers with length a to b, and we also have to make sure that we don't exceed the maximum string length every time. So every time we'll add a new digit to this decimal number by converting it from binary to decimal. Also another left shift and add an extra number, I plus j. But meanwhile, we also have to keep track of the length and the count of how many numbers we have. So here j, it will represent the length, and here what this does, one left shift 12, this is basically the same thing as 2 to the power of 12. And we know that the maximum length, so this basically represents the length, and so we basically reserve 12 spaces for the binary numbers, and we know that the maximum a and b are 12, so we'll set this to 12, and I added a 5 just in case of any extra spaces or anything. So this loops from a to b, always increase m using this method, and then afterwards we will count the frequencies and add them into our answer vector, which will sort afterwards to get the maximum frequencies. So here we will only check those ones with length a to b. We don't want to check anything other lower than that or greater than that. And here I will get the maximum of our number. So now we'll test each of the numbers that we added from here, this m, and we know that it cannot exceed 2 to the power of I, because if it's equal or greater than that, then we will have a binary number with a greater length. So anything with a length less than that, we might be able to construct it using a substring of a to b length. So here we'll count the frequencies of this number that we have, and then we have to check. Just to save more space, we can also add, we don't really need this, we can add it straight into the answer vector, or we can compare if this is greater than 0. because if it's 0, we know that we shouldn't add it. If it's 0, it's just empty. And then I created a structure here. This structure is basically the same thing as a tuple, but then I used tuple, tuple, whatever you want to call it. But I created this just to make it more specified. So this first number will keep track of the frequency of the value, and this second integer will keep track of the length of our this will keep track of the length of our decimal number in the binary form. And the final one is the value of the number in the decimal representation. So these are the ones that we will add. So first is the frequency, the count, and I will be the length of this current integer, and j is the decimal value of this integer. And then we will sort this, and we will use this comparing function that I made here. So this will receive 2 of our binary strings because we are sorting a vector filled with binary strings. First, we will see if the frequency of those are the same or not. If they're not the same, then we'll just return the one with the greater frequency. And then we check if they're the same length or not. If they are not the same length, but they have the equal frequency, so we have to go on to a deeper level, we will return the one that have the smaller length. And if they also have the same length, we will return the one with the smaller value. So we'll keep this whole thing in order, starting by the frequency. And here, this is our answer size. I'll also use the C to keep track of how many binary numbers we've already printed out. So we want to print out the first few numbers with the n highest frequencies. So, and we also have to make sure that our C is smaller than the answer size, because if C is greater than or equal to the answer size, that means we've already run out of answers to print. So we can stop this loop right away, even though we didn't print the n's highest frequency yet. So first we are at this index C, and we will print out the frequency at answer C. And here is just converting this into a binary number and printing it out. Because remember, first we stored in the decimal numbers here. And here, this bit, we will use the bit set data structure from C++. This one requires a constant integer value, so this is the length of the bit set, and we know that the maximum length is 12. So we will set this to 12 first and convert our answer C decimal into a binary number. Then we will, but we don't want to print out this whole thing because we don't want the extra zeros at the front. So we will have to loop through the length of our answer, which we stored as well in our structure. And also we have to loop until it's 0 and print out each of the digits at that binary number. Now we know that we printed one of the numbers, so now we have to increase C by 1, and this T will be used to keep track of printing the new lines, because it stated that we have to print 6 to a line unless we have fewer than 6 remaining. So we now already printed 1, and we will print all the rest other answers that have the same frequency as this current frequency. So we need to check that C is smaller than M. We don't want to exceed the answer size, and we also have to check that answer C's frequency is the same as answer C minus 1's frequency, because remember, we've already increased C by 1, so now answer C minus 1 was the first answer that we printed out here. And we have to make sure that they have the same frequency so we can keep on printing them in a line separated by space. So this is also the same thing I did here. Convert this into a bit set and print out the digits. Now I increase C and T again, and we have to check if T is equal to 6. If it's equal to 6, then we'll have to print a new line and set T to 0 again. And so here's what this does. So when t is equal to 0, we know that we printed a new line. So if we printed a new line, we don't want an extra space in the front because it will give us some errors. So we have to make sure that this t is not equal to 0 when we print a space. And after we've printed all the answers with the same frequency, we now have to check if t is equal to 0 again. If t is equal to 0, we've already printed a new line, so we don't need to print another new line. But if it's not equal to 0, that means we've printed a few numbers separated by space, and now we need a new line to print out the next frequency and the next answer. So this also checks for that, and it will just keep on looping through this and increasing c and I until we've reached one of the limits.